In the last video, we covered how to handle debug symbols. Now let's take it to the next level. How to make use of your remote debugging functionality to work as fast as if the code were running on your own desktop. But why bother with remote debugging? It's simple. Some bugs only happen on the target hardware. Maybe you're dealing with a segmentation fault because the hardware isn't ready when the software expected to be. Or perhaps the device behaves differently than your desktop simulator, like an integer overflow because the embedded architecture handles data types differently. When your desktop says A, but your hardware says B, you need to be on the hardware to see why. Here we see our application running. This is a ship navigation application. You see an animation, but once the animation is finished, the app suddenly crashes. Okay, so let's find the line of code that actually crashes inside our application. You see, I have not yet started the application, so let's do this through the GDB server first. I run GDB server --multi, specifying the port and also specifying the application. It is now waiting to be run. On my laptop, I also start GDB and I connect to the embedded target with the target extended remote command. See, worked. And now it collected some symbols. I give it some extra symbols from the sysroot here from my laptop system. Now I can run the code, and after a few seconds you should see the application starting up here, doing its animation, and after it did its animation it will again crash. But this time we are connected and we will find the mistake. Ship runs, but the app should crash soon. There we go. It actually crashed, but it's stuck here. Here we see the application got the seg fault that we were looking for. And now we can write the where command and we will find a whole stack trace. And the stack trace will contain the location where it actually crashed. We see the first frames contain some symbols that we don't know. Inside libqt6 core was a put string, was a debug operator. But the first line of code that we actually understand is here in data CPP line 16. So we can look inside our code and see that inside the code we will have a lambda with a local variable that is captured as a reference. A classical mistake that happens inside Qt. So if we remove this part or just copy the variable out, this shouldn't happen anymore. We just fixed our problem remotely while running it here, but analyzing it on the laptop. Now let's talk QML. First, you need to make sure QML debugging is actually enabled in your project. You need to add definitions dqt QML debug to your CMake to achieve this. If you see a line in your output that says QML debugging is enabled, only use in a safe environment, you're good to go. Just a heads up, really only enable this in a safe network because it does allow others to potentially extract hidden information or trigger internal features of your application. Finally, let's discuss performance. Sometimes code that runs perfectly fast on your workstation feels sluggish on the target board. That's totally natural. Embedded hardware has different constraints and is possibly slower. If you want to find out why your QML feels slow, you need to profile it on the device. So here's how I do this. First, I connect to my device and I run the app with --QMLJS debugger, profile, and give it a port and tell it to block until I connect with my Qt creator. So when I run this, it waits until my Qt creator connects. With a Qt creator that is specially prepared, you will see how to prepare the Qt creator in the last video that we did. We can actually connect to the board while running the QML code. So when I start the QML profiler, it will allow me to connect to the board, and you see it starts up on the screen. Now I can profile the application And once I'm happy and I think I caught all the information that I want to analyze, I can stop the profile and inspect the performance of that QML program running. So I will see compiling cost, I will see creation cost. This all counts in for your startup. And I will see the runtime cost. Here you will see slow frames. So if you have a slow frame, you would see that in the runtime cost here. This is a great way how to analyze what's slow on your device while still working on your laptop. And that's how you master remote debugging. By bringing the power of your desktop tools directly to your embedded device. You stop guessing and you start fixing. Thanks for watching. If you found this helpful, check out the links in the description for more in-depth content from the KDAB team. Auf Wiedersehen and see you next time.